So the title of the paper is Du Châtelet, Hypotheses and the Theory of Principles. The one issue that seems to have attracted most attention in Émilie du Châtelet's philosophy is the place of hypotheses in her natural philosophical methodology. Indeed, this is the third in a run of 5 papers on this very topic at this workshop. So one could be forgiven for asking, is there anything more to say? Well, I hope in this paper to establish that there is. In my view, one cannot properly understand du Châtelet's views on hypotheses without a clear appreciation of the theory of principles in which it is embedded. I refer here to a meta-theory to which almost all early modern philosophers were committed, what I elsewhere call the neo-Aristotelian theory of knowledge acquisition. My central claim today will be that when read against the background of this meta-theory, some of the key features of her view of hypotheses that have hitherto been overlooked can come to light. They are, first, that for du Châtelet, hypotheses are principles. And second, that she's committed to a view that is equivalent to Newton's notion of proof by experiment. So I'm making 2 claims. Of course, there are many aspects and constituents of her views that can be explained or at least elucidated by an analysis of her sources and influences. And we've heard a little bit about that in a previous talk. However, the thrust of the paper here has to do with where du Châtelet's views on hypotheses stands in relation to the neo-Aristotelian theory of knowledge acquisition. And I'm going to call that NATCA for short. Sorry about the ugly acronym. So let's look first then at the theory of principles. The early moderns accepted that there are various different forms of knowledge, such as sensory knowledge and special revelation, but that the gold standard for knowledge, the most useful and valuable form of knowledge, is scientia, that which is derived or demonstrated from principles. Now, I've not had much luck in convincing many of my colleagues in early modern philosophy about this. And I realize that I've been pushing this claim for some years now and have elicited almost no interest. Yet I still believe in it, and I will try again today. The neo-Aristotelian theory of knowledge acquisition has this name because the bare bones of the view derive from Aristotle's posterior analytics. It can be summarized as the theory that scientific knowledge is knowledge demonstrated from principles, that the certainty of that knowledge is a function of the certainty of those principles. The ideal is to have absolutely certain principles which yield absolutely certain knowledge. It's not that this view of knowledge applies to the sciences, rather it is that this is what it is constitutive of to be a science. And the archetypal science in the early modern period was geometry. And as an aside, it's hardly surprising, therefore, that du Châtelet uses many, many, many geometrical examples. NATCA, in the early modern period, is best thought of as having 3 constituents: a theory of principles, a theory of demonstration, and a theory of the sciences. And I often use the coffee grinder analogy. The coffee beans are the principles. The grinding mechanism is the theory of demonstration. You might think of it Aristotle's syllogistic or some alternative. And the science is the coffee grounds, the ground coffee that comes out of that process. In our period, each constituent, each of these 3 numbered constituents of NATCA on the slide was highly contested. And each constituent gave rise to a range of pressing philosophical problems. However, the constituents themselves remained relatively stable in spite of these internal skirmishes about the details. The one major skirmish relevant to our concerns was the issue of the mode of epistemic access to principles. One strand of this debate was the question as to whether the principles are innate. And John Locke famously said, no, they're not innate. Hence the titles of the book, of the chapters of book 1 of the essay. And here they are. The first chapter is just the introduction, but the second, third, and fourth chapters are called No Innate Speculative Principles, No Innate Practical Principles, and other considerations about innate principles, both speculative and practical. The subject is innate principles, not innate ideas. Innate ideas are wheeled in at the end of the fourth chapter as a segue into book 2, which is all about ideas. Isaac Barrow, whose view predated that of Locke, would almost certainly have agreed with Locke's view on innateness and principles, except that is for the case of the principle of contradiction. That, he claimed, is innate. Now, I chose Barrow as an example because the principle of contradiction features prominently in Du Châtelet's own theory of principles, as we all know. But let's leave the skirmishes and return to our focus here, the theory of principles. One salient division in the typology of principles for the period is that between propositional and ontological principles. This is my terminology. I've been using it for a while. Both types of principle are found in Du Châtelet's Institut Physique. Institution de Physique. And here I just have a simple slide for us. For example, in chapter 8, paragraph 145, she says the following. All the changes that happen in bodies can be explained by these three principles: extension, resisting force, and active force. And it can be said that these three principles are sufficient and that the nature of bodies consists in them. Here we have ontological principles, things in the world. However, Du Châtelet is largely concerned with propositional principles, and in particular in chapter 4, which is our main focus today. Propositional principles are best defined functionally. They are the propositions from which the rest of the science is demonstrated. They can also be defined by their epistemic status, though this is a slightly complicated matter. For example, Aristotle said that principles had to be universal, essential, and primitive. Petrus Ramus, the late Renaissance logician, in his three laws, he said they have to be universal, essential, and convertible. And Francis Bacon was a big fan of this, of the laws of Ramus, and he thought that Ramus's take on the epistemic status of principles is the correct one. Other criteria were regularly appealed to with regard to the epistemic status of principles. For example, many said that principles ought to be self-evident, and we find this claim in Du Châtelet. Locke's chapter of maxims in book 4 of the essay is written against an over-reliance on self-evident principles, because self-evident principles had a particular name. That name is maxims. If someone's writing about maxims, particularly in a logic textbook, or someone like Locke, they're talking about self-evident principles, a particular mode of epistemic access to a principle. An example would be, whatever is, is. Anyway, whatever the epistemic criteria, all of these are attempts to guarantee the certainty of principles. Another criterion was indemonstrability. This is the question as to whether principles can or cannot be demonstrated from any higher principles. Much ink was spilled over this. However, Du Châtelet follows Leibniz in not plumping for indemonstrability. So much for the epistemic status of principles. Let's return to the typology of principles. While the typology of principles was highly disputed, the most common view was that there are three types. And again, this derives from posterior analytics, of course. Three types are axioms, definitions, and hypotheses. Hypotheses are often called suppositions. For those who adopted the Aristotelian division of common versus proper principles, another really common distinction you find in Leibniz and most people who have a theory of principles, Isaac Barrow and Marriott and others. For those who adopt this Aristotelian division between common and proper principles, axioms are common principles, as you can see on the diagram, and definitions and hypotheses are proper principles. That is, principles that pertain to a particular science. So an example would be light travels in rectilinear motion. That's a proper principle of the science of optics, and that derives from Euclid's optics. Well, as far as I know, the earliest statement of that is in Euclid's optics. There may be earlier versions of that. So let's look at the three types of principles in this aspect of the typology. There's many, many ways, of course, of carving out principles. We've looked at, other aspects of this topic, but let's focus on this now: axioms, definitions, and hypotheses. Axioms are those axioms that are proper principles pertain to all the sciences. Indeed, most philosophers accepted a hierarchy amongst the sciences, with metaphysics at the pinnacle, such that all metaphysical principles are common principles. And this is nicely illustrated, for example, in the schema of the arts and sciences appended to the preliminary discourse of the Encyclopédie, which appeared in 1751, a decade after our concerns today. It's also Du Châtelet's view, as we find in the final paragraph of the preface. Metaphysics is the summit of the edifice. This summit is so elevated that our image of it is often a little blurred. And this is why I thought I should begin by bringing it closer to you, so that no cloud obscuring your mind, you might be able to have a clear and unassailable view of the truths in which I want to instruct you. Of course, the locus classicus of this view is in d'Alembert's article in the Encyclopédie on the elements of the sciences, where he sketches this vision of this sort of reticulated schema of the hierarchy of the sciences, with metaphysics at the top. It's also prevalent, of course, in the Berlin Academy, in the writings of Samuel Faumet and others. But this is taking us away from Du Châtelet's theory of principles and into her view of the sciences. Let's stick with the theory of principles. So we go to definitions. Definitions are the second type of principle, and theories of definition abound in the period, with most, though not all, following the fault line of nominal versus real definitions. For some philosophers, definitions held a special place. Hobbes, for example, claimed that definitions are the only type of principle. All axioms for Hobbes are reducible to definitions. As for Du Châtelet, in the Institut Physique, she does not present a theory of definitions, but her commitment to them in the context of Natka is apparent, insofar as she begins many of her discussions of physical concepts with definitions of the entity at hand. Thirdly, hypotheses or suppositions. The third type of principle, that which concerns us here, is hypotheses. One of the legacies of the emergence of experimental philosophy in England in the 1660s was a strident opposition to hypotheses. From some of the earliest writings of the Fellows of the Royal Society down to the likes of Thomas Reid, the Scots philosopher in the late 18th century, philosophers and natural philosophers alike decried the use of hypotheses. Indeed, one of the most vocal critics of hypotheses in France in 1740 was Voltaire. Now, while the explanation for this anti-hypotheticalism is multi-causal, there is one simple and very persuasive fact that loaded the dice against hypotheses. If, according to Natka, scientific knowledge is derived from principles, and hypotheses are treated as principles, then what is demonstrated from those principles cannot be known to be certain. And worse, whole systems of philosophy, that is, speculative philosophies, are demonstrated from hypotheses, or what amounts to the same thing, uncertain principles. Indeed, the term hypothesis came to refer not simply to the speculative suppositions from which systems were derived, but to the whole speculative theory itself. And thus it's common to find the term the Cartesian hypothesis or the corpuscularian hypothesis, both terms that Locke uses in Some Thoughts Concerning Education way back in 1683. Let us turn now to Du Châtelet on the theory of principles and on hypotheses. Where does she stand in relation to Natka? Well, even a cursory reading reveals a full commitment to Natka. The title of chapter 1 is a dead giveaway on this point, of the principles of our knowledge. Then the opening lines of section 1, paragraph 1, that is, the very first sentences of the book after the preface, say, all aspects of our knowledge are born from each other and are founded on certain principles, whose truth is known without even reflecting on it, because they are self-evident. In the very next paragraph, the view is reinforced after her warning to avoid the excesses of the imagination. So one must substitute demonstrations for the illusions of our imagination and not admit anything as truth except what results incontestably from first principles, that no one can call into question, and reject as false all that is contrary to these principles or to the truths that one has established with them, whatever the imagination might say. So Du Châtelet is committed to Natka. How then does she define principles? We've already seen that Du Châtelet accepts implicitly the ontological propositional distinction between principles. But what about her definition of principles? Well, paragraph 2 promises to define what principles are. This is in chapter 4, but she never delivers on that promise. Instead, she criticizes one of Descartes' criteria for principles, namely that their constituent ideas be clear and distinct. And this is, in fact, the view of Pascal and Arnaud and Nicole. This the lack of a definition, therefore, in this paragraph by Du Châtelet shouldn't raise a problem for us because her view on the nature of principles is clear from what immediately follows. By the way, Pascal has quite an interesting and sophisticated theory of principles, and that's borrowed by Arnaud and Nicole in the Logique. So let's then look at Du Châtelet's higher order principles. One characteristic of Leibniz's theory of principles and those of his followers is the ranking of principles. Paragraphs 31 and 32 of the Monadology are just one of many expressions of this. Like Leibniz, Du Châtelet ranks the law of contradiction as the first principle. When she says it's the first truth, quote, on which all truths are founded, she doesn't mean that truths are founded exclusively on this principle, but that this is one of the principles on which all truths are founded. It's the foundation of all certainty in metaphysics as well as mathematics. Paragraphs 4 and 5. It also provides the basis of her definitions of possibility and impossibility, a topic we won't have time to get on tonight. Onto today, I should say. It's evening here. I keep thinking it's night time where you are. Okay. The second principle is the PSR, principle of sufficient reason. And again, we don't have time to discuss that here, though I find that her treatment of that is very interesting as well. Okay. Another point within Du Châtelet's theory of principles, or the implicit theory of principles in her work, is that she believes that laws of nature are principles. She says so explicitly in chapter 11 when referring to the 3 laws of motion. She says laws that can be reduced to 3 principles. Okay, and then she gives the laws of motion. Of course, by 1740, this was the standard, indeed the inescapable view about laws of nature. After all, what is it that principia, the term principia, refers to in the title of Newton's magnum opus? It's laws of nature. Yet even in Descartes, it only took just over a decade between Le Monde and the French edition of the Principia, of the Principe, for Descartes to refer to his laws of nature as principles. So if Descartes introduced the notion of laws of nature into Western thought, it only took him just over a decade to move from talking about them as rules and laws to talking about them as principles. So we come now to the heart of the paper. Du Châtelet's views on the nature and role of hypotheses. It will hardly surprise you after this lead-up that Du Châtelet, like the rest of her generation and her forebears, regards hypotheses as principles. This is clear from very early on, as early as the preface at paragraph 8. There, she speaks of hypotheses functioning as principles. She says, all of astronomy, for example, is founded only on hypotheses. And she goes on to speak of them as principles. She says, quote, the mind applauds itself for having found these subtle principles. Again, in the chapter on hypotheses, Du Châtelet calls hypotheses principles. When a hypothesis is made, one must have reasons for preferring the supposition on which it is founded to all other suppositions. Otherwise, one spews forth chimeras and precarious principles that have no foundation. Hypotheses are precarious principles in this quote. These words express the standard anti-speculative tropes about the dangers of using unfounded hypotheses as principles, namely chimeras and precarious principles, and we might add castles in the air and so on. But the key takeaway from this passage is that for Du Châtelet, hypotheses are principles. This, I believe, has been overlooked in recent discussions of her views on hypotheses. Yet the view that hypotheses function as principles in the generation of a science is at the heart of early modern anti-hypotheticalism, an anti-hypotheticalism that motivates Du Châtelet's discussion of hypotheses in the first place. Next, probable hypotheses and proof by experiment. The theory of principles requires that the principles of a science be absolutely certain. Thus, the prime candidates were propositions such as essential definitions. Aristotle uses all humans are rational animals. Or else they're self-evident truths, and the ones that are kicked around a lot in the early modern period, nothing can both be and not be at the same time, and so on. However, as experimental philosophers began to generate more and more knowledge based upon observation and experiment, and as new laws of nature were discovered, laws which to all intents and purposes looked like and functioned like principles, it was becoming clear that experiment itself can provide extremely strong evidence for the certainty of principles. This development is reflected most clearly in Newton's first edition of the Principia Reflections on methodology in natural philosophy, so Newton after 1687. Newton claimed that experimental philosophy is just bringing experimental evidence to bear on propositions to the point that their epistemic credit rating, while not as good as Euclidean axioms, is as close to absolute certainty as we need. I'll say that again. Newton claimed that experimental philosophy just is bringing experimental evidence to bear on propositions to the point that their epistemic credit rating is as close to absolute certainty as we need. In experimental philosophy, the word hypothesis is not to be taken in so large a sense as to include the first principles or axioms, which I call laws of motion. These principles are deduced from phenomena and made general by induction, which is the highest evidence that a proposition can have in this philosophy. Okay, we can't demonstrate them, but they're pretty certain. And the word hypothesis here is used by me to signify only such a proposition as is not a phenomenon, nor deduced from any phenomena, but assumed or supposed without any experimental proof. Principles like laws, my laws of motion, they're proved by experiment. Hypotheses, those principles are not. Newton is explicitly demarcating between hypotheses as principles and axioms, because hypotheses, quote, are supposed without any experimental proof. That is, they function as empirically unverified principles. This method by which principles such as the laws of motion are made certain, he called proof by experiment. And it's embedded in the optics, as we can see from the following images. Just look at the arrows. We don't have time for any discussion. I'm just about through. There were precedents for this reasoning and the terminology of proof by experiment in Pascal, in Boyle, and in Marriott. But it was Newton who wrote most about it and who wrote about it in the queries to the optics, which Du Châtelet had carefully read. This, I believe, is the background to Du Châtelet's claim about the probability of hypotheses and the ability of experiments to increase their probability. Thus, at paragraph 58, she says this: if it is found that these experiments confirm an hypothesis, and that it not only explains the phenomenon that one had proposed to explain with it, but also that all the consequences drawn from it agree with the observations, its probability grows to such a point that we cannot refuse our assent to it, and that is almost equivalent to a demonstration. Exactly Newton's thought, as expressed in query 31 of the optics. Du Châtelet is claiming that experiment and observation can confirm an hypothesis to the point that the proof is almost the same as a demonstration, and it can therefore be taken as a principle of natural philosophy. Compare 31 of the optics. And although arguing from experiments and observations by induction be no demonstration of general conclusions, yet it is the best way of arguing which the nature of things admits, and may be looked upon as so much the stronger by how much the induction is more general. We can't get demonstration in natural philosophy, but we can get pretty close with observation and experiment. Indeed, looking back to 1672, to Newton's first optical papers and correspondence, we find him claiming this: I should take notice of a casual expression which intimates a greater certainty in these things than I ever promised, namely the certainty of mathematical demonstrations. I said, indeed, that the science of colours was mathematical and as certain as any other part of optics, but who knows not that optics and many other mathematical sciences depend as well on physical principles as on mathematical demonstration. Distinguishing between physical principles and mathematical demonstration. And the absolute certainty of a science cannot exceed the certainty of its principles. Now, the evidence by which I asserted the propositions of colours is in the next words expressed to be from experiments, and so but physical. Whence the propositions themselves can be esteemed no more than physical principles, rather than mathematical principles of a science. So experimental confirmation can raise the probability of an hypothesis to a level that is virtually absolute certainty. That is, proof by experiment can turn a hypothesis into an axiom. Thus, Du Châtelet says of Huygens' argument for the ring of Saturn, quote, this correspondence between hypothesis and observation has finally converted this supposition of Monsieur Huygens into a certainty. There's much more to say about Du Châtelet's views on hypotheses than we've covered here. Yet I hope that I've established, first, that for Du Châtelet, hypotheses are principles, and second, that the method of experimental confirmation of this form of principle is equivalent to what Newton called proof by experiment. Thank you.